I would say that the number one takeaway is to invest in experimentation infrastructure early because that will be your sort of compass for figuring out how to escape from prompt hell and deliver results for both your users and your business. This talk is titled Breaking Free from Prompt Hell, and today we're going to explore a workflow of how to develop a systematic approach to measuring, improving RAG applications. And we're going to go through four different sections. The first one is what is prompt hell? It's a term we've been using a lot. Then we're going to talk about evaluation, then experimentation, and finally optimization. One of the main things we're going to get out of this is how do we move away from the reactive firefighting with customer complaints, people coming in saying, hey, this doesn't work. I don't like how it did that. And how do we move towards some proactive optimization? How do we move away from guesswork and go towards data-driven decisions? And to start off, we're going to describe what prompt hell is, which is those loops of trial and error prompt fiddling. I went to engineering school. I did not finish engineering school, but one of the key things they do say is engineering is when you're very specific, you're very meticulous, and prompt engineering does have some specificity to it, but more often than not, it feels like trying to whisper the magic incantations to get the LLM to do what you want it to do. And there are some real costs and pains to prompt hell. There's engineering time where you spend endless tweaking cycles. Sometimes we've worked with people who've been prompt fiddling until 2, 3 a.m. to get out of the hellhole they're in. There's technical debt in terms of undocumented and untested changes. There's a lot of learning that does happen in the active loop of prompt fiddling that isn't necessarily documented, and other people on the team are not able to benefit from that. Trying all these different variations does lead to spending more on API costs, and spending more on APIs is good insofar as you know you're systematically getting to a better result. And finally, there's this massive opportunity cost because you spend your days firefighting problems for your users instead of building value add functions. You want to be able to say, hey, I built this feature, I delivered it, I squashed some bugs, let's move on to the next one. And unfortunately, in the current paradigm of building AI apps, you end up spending a lot of time trying to support and fix bugs ad hoc. And you get into this really frustrating game of whack-a-mole where you see an issue, you try to fix that, and then another issue pops up, then you try to fix that, and you just keep trying to whack those moles. You spin your wheels, and what do you really have to show at the end of it? And RAG makes prompt hell even worse because now there's multiple steps in your pipeline. You might have some ingestion indexing prompts to transform the documents as they're coming in. The retrieval quality is something to consider. You might have a query rewriting step and then the generation as well. And making a change somewhere in the system is going to have cascading effects to other parts of the system. So that's the problem. And now how do we get around to solving this? This is where evaluation comes into play. And everybody's heard of evals. Everybody knows about evals. I hope you know about evals for hallucination or recall. These are some very useful things. And the takeaway for this section is that what gets measured gets managed. It's that old business school adage. And this talk is structured in the form of like, how do you go from zero to hero, right? So we're going to start off from the very basic of, okay, you're building some AI feature. And so what are you going to do? You're going to write your best guess at a prompt. And then you're going to start running it with some example inputs. And one key thing to be aware of here is you want to make sure that your example inputs are representative of real use. They are challenging and they're edge cases. And there are also edge cases involved. This is sort of what you would do if you were building a regular code base with some functions that are very important. You're going to test the main functionality. You're going to test some challenging functionality. You're going to test some edge cases. Think about the last time you implemented, I don't know, test for a recursive function. What you put an empty list in, how does it behave? You put a massive list in, how does it behave? You want to make sure that your eval set is representative of real use, that it has these edge cases captured and also has some challenging ones as well. As you're going through this, you want to save inputs and outputs to create your eval set because no one ever regrets creating a representative test set of 10 examples or more, ideally more, the more the better. But at the minimum, it really speeds up your iteration process if you can capture some of these inputs and outputs into a data set so that as you make prompt tweaks, you can run that eval set again. And this is foundational because it sets up the foundation for the iterative learning process that occurs when you're developing these AI apps. You might go and show your AI app to another key stakeholder, and they tell you of another input that you didn't fathom. You should add that to your eval set. You're going to get feedback from others. You should add that to your eval set. This is super important because I can't think of anybody who has figured out all the requirements for their prompt up front before writing examples. The requirements and the edge cases and all that, they come iteratively as you're experimenting with different prompts and trying out different inputs. And this is how often people get to the looks good to me at 10. It's okay, we've run this with 10, 20, 50 examples, looks good to me, let's ship it. Some of you might be wondering, should we use synthetic data for 0 to 1? I would say if you don't know how users would use your system, you have a bigger problem. You should understand your users and understand what sort of things they're going to be asking of your system so that you can have something that's representative. It can feel like it's kind of a roundabout way to create 10 examples if you go and you create a pipeline for creating synthetic data for those. You're building a chat with your documents, get some documents, read through the documents yourself, wonder about 10 different questions, consider the types of questions. Is it about a precise section in the document? Is it about multiple sections in the document? Maybe you have multiple documents. Maybe there needs to be some aggregation. Consider all of these different scenarios and user stories to inform how you construct your eval set. Now that you have your eval set, you also need to have meaningful and reliable evals. These are two adjectives that I want to define. One is meaningful. And a really good sort of compass for this is what moves the bottom line. So in our conversations with Jason, he mentioned like recall is a very important, meaningful metric. Are you retrieving the correct documents? Are you getting all the relevant documents to answer the user's query? That is a very meaningful one. If somebody comes to you and says, look, I want this to sound vibier, sound better, I would question that and say, okay, why do you want this to sound vibier? And then they might come and say, well, I think it's going to create a better product experience. And then you might question them again and say, why is that valuable? And then they might say, oh, it's going to like lead to more usage of this feature. And you're going to say, aha, so usage is a KPI that matters to me. And now I need to be able to think about how to craft an eval that links to KPI. And vibes was just some intermediary for that. The second property of good evals is that they are reliable and they consistently evaluate in the same way. A lot of the work that we've done in the past has been around helping people create reliable LLM judges based on a scoring rubric. So you've got the ones you might have had in school where there's multiple dimensions. Each dimension has different scores. And what we've found is that the more you can decompose this rubric or whatever it is into individual LLM as judge binary classifiers with very specific, unambiguous like task descriptions that are simple enough that even Llama 8B could do it, the better you're going to be. Because those are it's much easier for those to have like a 90% plus quality, accuracy or precision or recall or F1 than it is to do something a bit more ambiguous. One other thing to zoom in on this a bit more is this idea of filtering with F1, but then selecting with kappa. And this is important because what we notice is that most often people are looking at F1 scores to figure out, okay, is this like a good judge? And that is important. That is important. That's why we want to filter with F1. But we also want to select with kappa. And what is kappa? So we created a little playground for this on Claude. And there's two of these because Claude couldn't fix it. And let's say you have a agreement of 80% between your LLM judge and your human judge. All right. And so if the LLM says it's good, the human says it's good, both of them said like 60 of them were good. And then we have the slider here, which is like how many of the 100 examples did the LLM say was bad, and it adjusts the numbers on the rest. As we adjust these, we can see the precision, recall, and F1 scores for the good class and the bad class. Right? It really depends on what you're doing. If you are a bank and you want to catch fraud and you want to label those fraud things as bad, then a recall of 100% is going to be more important for you. If you're maybe a B2C app and you want to be more sure that when something bad comes up, that you're very precise about it, then you want to focus on precision on that front. And the other thing to notice here is this kappa. So what is kappa? What is this thing you've mentioned? Kappa is the measure of agreement beyond chance. Your LLM as judge might have just memorized the distribution, but is it actually understanding how to agree and how to judge like you're judging on something? So if you adjust this, for example, you'll see that the kappa is now 0.375, and the observed agreement was 80. The expected agreement based on just pure probability was 68. And the agreement beyond chance, this is what kappa is measuring, is this yellow bar over here. There's this interpretation. This is the formula for Cohen's kappa. There's also an interpretation of it. One thing we have also discovered is that these kappa scores, even though it's from -1 to 1, they actually need to be normalized. There is a max kappa score depending on what your total agreement is. And we have to do the math on that to get back to you. But a more real world example of that is this is is there too much jargon LLM judge that we helped calibrate for a customer of ours. And we threw a bunch of techniques at it. We tried few shots, the static few shots. We tried dynamic few shots. We tried fine tuning with static few shots inside. We tried fine tuning with dynamic few shots, fine tuning with 0 shots, all of the above. And here we have the F1 scores. And just looking at the F1 scores, you might say, okay, there's this like 80%, 80%, 80%, 80%. Okay, let's look at these 4 80%. Let's pick from one of these to be our LLM judge. Then we want to look at the kappa to select which one ought to be our LLM judge. And over here, we see that the highest kappas for those is this 65.5 and this 69.69. It's a relatively simple decision here. This row has both the highest F1 and the highest kappa, and it was trained with 40. It was a fine-tuned GPT-4o mini trained with 40 examples. But if this row wasn't there and we hit it, now we have to decide between this row of a kappa of 0.645 and an F1 of 8.84, or this row of a kappa of an F1 of 0.82 and a kappa of 0.65. In some situations, you might say that actually, yeah, the F1 is a little lower, but I want there to be more agreement between my LLM judge and my human labels. So this was a little side quest into kappa. And you want to regularly revisit these alignment scores with human labeled eval data to ensure that there is alignment. Now you've got your eval set, you have some evals, you've measured a baseline by this point. What do you do next? Now we get to experimentation. Amazing. And you saw here, we tried a bunch of experiments, right? We tried 0 shot, we called it with 0 shots, we called it with few shots, we called it with dynamic few shots, we fine-tuned in all these sorts of ways. Fact is, there is no silver bullet, folks. You just have to try a bunch of things and see what works best. That's really it. And the way you can really make the most of experimentation is you want to get some real world data. So whether that means launching or doing some private beta testing, get some real world data in your system, experiment and evaluate on that. Let users give you feedback. And once they identify some failure cases, add them to your eval set. This way you know that you're solving those failures as you iterate on the prompts and the models underneath. You want to have tracking and reproducibility, right? You want to version control your prompts. You want to know that this prompt or this chain of prompts and this chain of models got me this score. And these were the evals that did it. You want to have the logs there. Sometimes it looks like you're like, oh, I'm trying to optimize this thing. And this has happened to us before with our customers. Like, I'm trying to optimize this thing and I just can't get it to get better than 89%. And then we're like, have you tried looking at your data? And then they go into the data and they realize that actually they had a data issue and the real number was like 96%. So you should go look at your data. And this is just best practices for looking at your data and being able to see the chain, the consequence chain of your decisions. Another useful thing when you're doing evaluation is to not forget statistics. Sometimes slight variations in performance are a result of noise. Even with a temperature of 0, these models are non-deterministic. So you want to run multiple trials and significance tests if you really want to be confident in the assertions you're making. It is a bit harder to do at smaller data set sizes, so you might skip them, but once you have enough data, it's helpful to bring these in. One of the little helpful tools we built for this is the McNemar sample size calculator, which tells you what the size of your test set needs to be able to derive statistical significance. Let's say you have two binary classifiers and you want to compare them. You want to make sure that one is significantly better than the other. You want to be 80% sure that one is better than the other. That's this one. Over here, you expect the new classifier to get 8% of the cases correct, 8% of the cases correct that the old classifier didn't. And over for the P01, you're okay with the new classifier getting 2% of the cases that the old classifier got right, getting those wrong. And this will show you that you need to have 219 items in your test set to come up with a statistically significant conclusion. When you're running a lot of experiments, how should you think about that? You probably should only modify one component of the system at a time. So in your RAG, you might have multiple steps. You might have some ingestion steps, some query, some retrievals, some query rewriting, all these different things. Keep everything frozen, play with one, see how it affects things downstream. And often you will be able to, but by looking at the kind of failure you see at the end, you can infer what step of the chain caused that error. It can be helpful to use a gateway or proxy like Portkey or LightLLM with semantic caching for those static parts. You don't want semantic caching for the part you're playing with, but for the other parts, this way you can, benefit. You don't have to wait as long for the LLM to generate its outputs, nor do you have to pay for it. And you can also progressively scale from small sets to larger sets. So you found some errors. Great, just run that error set and see if you can fix it. And then once you can't fix it, you can go to the other examples you had, see how your changes affected those and whether there were regressions. Grouping related variance is kind of like the same thing as two. And now that you've done that, now you have some evals. You have your eval set, you have your evals, you have a baseline, you have tried a bunch of experiments. How do you think about the optimization for those experiments? How do you think about those things? And there are many techniques. There is no silver bullet. This is what I said at the beginning. You just have to try a bunch of different things, but you have to try them in a systematic way that is reproducible. Right? One of my favorite techniques here is the validate regenerate method that Jason mentioned at some point, I'm sure, where you can use pedantic to validate the output and regenerate it. Healing is always going to be better than evaling at the end. Go look at learnprompting.com to see what techniques they offer. Isolate that component in your system, try different techniques, see what makes sense. If you're wondering, okay, do I do static few shot or dynamic few shot? I'd say try both. And sometimes even a combination of both is helpful. So one of the things we found is that, so we were working on a new optimizer for DSPy that did dynamic few shot and static few shot. So what it would do is if you said I want like 5 examples in the prompt, it would try having 0 static, it would try having 1 static, 2 static, 3 static, and then the remainder being dynamic. And on the RAG test sets of Hotpot QA and Hover Retrieve, we found that the optimizer found that having some static examples was actually helpful for improving the scores versus having them all be dynamic or having them all be static. Fine tuning is really helpful when you have fine tuning with OpenAI specifically is really helpful with small amounts of data. You can get some results with even 10 examples for the fine tuning. You want those examples to be representative of real world usage. And when you are fine tuning with OpenAI, this is hidden in their docs, you want to inject the static or dynamic few shot examples into the fine tuning JSON-L. That's going to help. You might say, do I do static or dynamic? I say try both, experiment with both, see what works better for use case. For RAG specifically, you might want to look at contextual RAG. When you're taking in the documents, you want to do some pre-processing on them with LLMs to augment them. That is very helpful. One of the techniques that I was doing pre-contextual RAG was I take a document, segment it into sections, take each section, have an LLM turn that section into facts that were atomic facts, and then another LLM would take those facts and turn them into questions that are answered by the facts, and then you'd embed the questions. And then at query time, you'd have the LLM ask questions, do an embedding search on the questions, retrieve the relevant facts, put them into the prompt. That can maybe be helpful for optimizing your RAG pipeline. And for the retrieval step, for example, you might want to optimize for precision and recall simultaneously. So you might consider ensembling two different LMs, one that is really good for rewriting the query to maximize precision, the other that's really good for rewriting the query to maximize recall, and then combining the result set from both of those. And I brought this slide again because these optimizations don't happen in a vacuum. You want to get real world data. You want to let users give you feedback. You want to continually add stuff to your eval sets and measure your iterations against the eval sets that you have. And this is what we've just gone through is, I'd say, a workflow for moving from this like reactive firefighting regime of I YOLO shipped something and now users are complaining and now I need to play prompt whack-a-mole to feeling a little zen in how you're building all these apps. And it lets you, wait one sec. And this lets you move from guesswork to data-driven decisions. Somebody may have booked this room, so we'll see. So what are the takeaways from this talk? Get your data first, then get your evaluation second, do experimentation to optimize, and create feedback loops in your system so that you can incorporate learning. Awesome, that's great. You can incorporate learnings from real usage into your eval harness so that you can iterate against those. Thank you for coming to my TED Talk. Now's the time for Q&A.
Is your room okay?
The room is okay. I got this for the next 30 minutes.
Okay, perfect. So as always, we're probably gonna do like 3 or 4 questions from the Slido, and then we'll just jump on to live questions. Let me just change my windows real quick. Can you provide more clarification on how to break from the prompt hell loop? Can you give some real world examples or case studies you had with customers?
Oh, okay. How do you break from the prompt hell loop? My follow-up would, my first question would be, I imagine you have something, it's out there, now users are complaining. One thing that you can do here, if that is the case, is you want to be able to take in the user feedback. You can do some clustering or segmentation of that. That will identify different eval sets for different problem cases. And then you can go and tune your system, experiment your system to squash the errors in those different segment eval sets. That is something that, from what I've heard, Replit used for their Replit agent.
So I guess another question, I mean, this is almost very similar but different in some ways. Is it possible to develop a generalized evaluation framework that can serve as a foundation across multiple industries?
I don't know if you can have a generalized set of evals, but I believe you could have a generalized eval generator.
Can you elaborate?
One of the things we're exploring at Zenbase is how do you generate reliable evals, ones that are human aligned, and that, how do you have a pipeline for doing that? And so that could be general across industries, but other than hallucination and recall, I don't really know what would be the set of general evals that would work in every industry. Everything we find often evals are very domain specific, so that's why I would hesitate to say there's one set of evals that covers everything. Oh, Jason, you're muted.
Oh, sorry about that. How can you build evaluations to be tailored to measure performance for subjective, user-specific tasks? And I can imagine situations where different users are judging the same labels.
Yeah, that's a fun one. There's going to be some disagreement between your labelers or your judges already. And so if you're trying to calibrate an LM to judge like them, it's going to judge like the intersection of their agreement and not the. That's a fun one. How would you do that? I think so. One of the things we've done is we have one labeler, we have one expert labeler, and then we get an LLM to judge like them. We have also worked in situations where there are multiple labelers. When we did do that, it worked as well. It worked the same in terms of kappa scores, actually. It was roughly the same. I'd have to see more about the problem to offer more targeted feedback on that.
Yeah, I can add to this as well. I think it really depends on whether or not the intra labeler variance is noise or that they're actually judging for different things. And you can basically figure this out by looking at the alignment across judges. So if you find examples where multiple judges label different things, ideally two things happen. One, you try your best to make labels binary, and so agreement and disagreement is very clear. And then when you find disagreements, you have to recognize that if they are disagreeing, but one of them is incorrect and there is a right answer, you need to change your labeling policy. If they are disagreeing, but both of them are right because there's some other category, then there should be a separate labeling task, right? And so this happens a lot in the Zapier example where in the beginning, like all the labels are just like, how did we do? Good or bad? And some people would say it's bad because the answer is too long, whereas some people would say it's bad because the formatting is not correct. And you just have to make two separate labels. You have to go talk to your labelers, look at your data, go, no, no, it's not good or bad. It's did it follow the formatting or was the answer too long, right? And so you got to figure like what that case is.
I want to riff on that a
Yeah,
further. One of the points I made on the eval section is to decompose your evals. And so if at the beginning you have your labelers saying this was good, this was bad, this was bad, great. What was good? What was bad? What are the properties of all the good ones, of all the bad ones? The good and the bad is trying to coalesce so many different small things. And even though that is a binary classifier, it's not a specific, unambiguous binary classifier. So from all those good, bad labels, you may end up with a set of 12 hyper-specific binary classifiers. Is the formatting good or not? Was there too much repetition? These things are all this, and what is repetition even? That's not even a hyper-specific one. So you need to be very specific with your LLM judges and also your human labelers. And sometimes that starts with just yes, no labels. Sometimes you create a rubric. It's quite an iterative process to come down with very specific, unambiguous natural language checks.
I definitely agree. Let me see how many upvoted questions. Okay, maybe we'll do like three or four, then go live. To what extent do you see models improving your prompts versus just tweaking them by hand? I think here it's mostly going to be around whether we have evals to hill climb, but I'd love to hear your answer.
I think that improvement is relative. I think that the models will generally get better. I think that what often happens is that prompts are underspecified from expectations. And so I think of prompting as the communication of your expectations and your intentions for an LLM. And if you have underspecified your expectations and intentions, then the model getting better won't necessarily do anything for you.
That's a pretty strong answer. I would also say here, it really depends on whether or not you have good evals to begin with, right? I think if 100% is the highest and you have something at 60%, there are going to be techniques in the future that help you get to that specification. But I think what's happening in real life is just because people only have 6 or 7 examples and currently 6 of them are perfect, too many teams want to have very high scores. But what that means is you can't actually go climb because you're kind of at the top. And so a lot of the work there too is also about expanding your eval set to actually be harder, where if you actually have something that's like 50% accurate, now you can hill climb a little bit more. But 50% accurate with 100 examples is very different than 50% accurate because you have 2 out of 4 failing. And a lot of that is going to be pretty important. I'd also say the second call out there is whether or not you have a good library of few shot examples. If you have a library of like 400 few shot examples, there's probably something you can do to figure out what is the best 20 to choose. But again, most of it is the work that you do to help the model rather than the model actually doing the work for you. The model is going to solve the problem of search, but you have to give it the space of what to search. Oh, this question is good. So, what open source projects do you wish existed that don't exist, and where do you see opportunities for the community to contribute?
Open source projects exist on it, and where does I think that it is very early days on this like automated prompt engineering train. It may seem very opaque, it may seem like it seems very complicated, but actually when you get down to it, you'll find some simplicity there. And we're at the place where it is a a deep ocean that has only been shallowly explored, and shallow exploration will actually be industry leading research. Optimization algorithms is one place that if I summarize DSPy's existing optimizers, it's like try random few shot examples to find which are the best. That's one of them. The other is like look at the source code and some examples and the existing prompt to suggest better prompts with some heuristic ideas. It's the other one. And then the latest one is like you're doing classification and here are like the examples that were class A and here are the class B. Infer some rules that will help you decide how to classify things. Those are very like really simple prompt optimization algorithms when you frame them that way. It's just been wrapped in all of this complexity. And so if you can sort of breach that complexity, there is opportunity to do cool things there. I think that the ELL library is really cool. L is a really cool approach to things. And I'd like to see more things like that, but async first, especially on the TypeScript side. If you're asking about like what openings are there, I know that TypeScript is underserved relatively. Master AI is doing some really cool work on that right now. And there are some engineering teams that are just getting into AI and they are like Go users. When's the last time you heard about like a new agent library for Go? So I don't know, taking LangChain and having Claude code, LangChain core and having Claude code write it for Go, maybe taking L and writing it for Go. Like I think that if there are these niches that are open, if you just build something, intuitive for that language. Python is very saturated. There's a lot of tools. It's probably 12 different eval tools and 42 different observability platforms. But on the like Go side, there's something there. There's a bunch of Go engineers from Netflix writing back in code that are just like dying a little inside, having to write Python microservices for the AI things. So that's one side. That could be one thing. I think and lastly, I'll say this. I think um, a lot of tools are based on different batch processes and something like a iterative prompt development system encapsulating a lot of what I talked about today or different tools for different parts of it could be particularly helpful because, and this isn't just me saying this, but I'm referencing Shreya Shankar's like who validates the validators and other papers of that ilk. You don't know what you expect until you iterate. And then as you iterate, you figure out what you need. And nobody really knows what prompt you need at the beginning and the answer.
Yeah, I'll also add, I do think there's a lot of tools around just like data analysis of conversations that are really lacking. I think we talk about clustering a lot and how to clustering to look at data, but most of these things sort of exist in notebooks and don't really have general tools. I don't know if like any can exist right now, but like, that style of analysis has been happening for like a decade now. So I think I wish I saw more tools on that. One last question before we jump into live questions, just because I think I called you out on this before as well. What does meaningful and reliable mean to you? So you say meaningful and reliable evals.
Yes. Okay. Meaningful means that if you're trying to go from point A to point B, a meaningful sort of compass is one that gets you from point A to point B. But it's not meaningful if it's orthogonal to you getting to point B. So the evals that you have are supposed to help you get to point B. And sometimes those evals can be your best guess at what gets you to point B. The prompt I offered is question the eval you are given. If somebody gives you an eval, says, I want this eval, other than hallucination and recall, those are pretty like standard. If there's more of a vibe eval, question it, ask why this vibe eval matters. And often maybe you will get to some metric for the core business. And then that is actually your true eval. Is my LLM doing things to drive the business forward? And that is the true eval. Now you have to figure out how to break that down. Reliable, I believe, is the combination of an F1 score and a kappa score. So the F1 tells you how you're doing on precision and recall. The kappa score shows how aligned it is with your human graders and not what the LLM thinks itself. And sometimes we've done this. we get the LM to output in its grade, and the human graders are like, wait, actually, I think that's right. Like my grade's wrong. So you kind of have to find the balance between what the LM says and what the human graders say, and the agreement between that, all of those. And when that agreement is high, then it's reliable. But oftentimes, just a bare prompt into an LLM will get the LLM to judge like it judges, and that is not necessarily the vector or the angle you want to approach things with. You want to have the judge or the automated judge judge the thing in the way you want it to be judged rather than the way it judges. No, you're muted,
Try to
Jason.
summarize this a little bit. So are you saying that like meaningful is more about like how does it correlate with sort of these outcomes, whereas reliable is more like how does it correlate with your own decisions or your own
Yeah.
labelers? Got it. All right. Let's try to open up any questions from the main group here. I think we can do some hand raising. Otherwise, I think one question I've been asking everyone is like, what is a question we have not asked that you wish we asked?
Can I ask a question about DSPY?
Sure.
Yeah,
Good.
if that's okay. So, do you use DSPI as part of your work? So you showed, for example, a real consulting example. I know you're a contributor to it, but when I've looked at it personally, it's hard for me to get my head into it.
Mm-hmm.
And I just wanted your opinion as someone that's worked on the project. Tell me how to on-ramp, A, and or B, should I bother or should I look at using Zenbase? Because I'd actually, if you could say a few words about your company, I was looking online. I feel like you're maybe a wrapper for it. So maybe just
Mm-hmm.
talk about what you're doing there. Because I
Okay.
finally found a DSPY expert and I need to ask the question. Yeah.
Sounds good. I'd say let's look at to answer this question, I want to look at the problems I believe DSPy is trying to solve. DSPy, as it exists today, is how do I, as a researcher, iterate on system architectures to find one that works to accomplish the task I want to accomplish and create a state-of-the-art system so that I can publish a paper. Implicit in all that job to be done is this is a tool for researchers. The ideal place to be working with DSPy is a Jupyter notebook. If you look at some of the defaults in DSPy, it has a bounded cache for
Mm,
LM requests, which you don't want to have in production. You can configure
right.
it
Yeah.
to not have an unbounded cache, but a lot of the design decisions are around that. Another of the design decisions for DSPy is you shouldn't be writing prompts. You should write these maps, these transforms,
Right.
where in reality, what we find is people already have prompts.
Yeah.
And DSPy's optimizers, in our experience, haven't been the best at taking a prompt and making it better, but they are good for taking no prompt and making it into a good prompt.
Okay.
So
Gotcha.
the way we have used DSPy in our consulting is to use it as a prototyping framework to explore the appropriate architecture to get good results. Because it's actually really good for that. I have a multi-label classifier, and this isn't doing that well. What if I broke it down into 7 binary classifiers?
Oh, I see. Okay. Makes sense.
Okay, and then let me run that, and then I see that it resulted in a 15% lift.
Mm,
Okay, maybe I should be approaching the problem that way, and then write specific prompts for each of
okay.
those things.
Yeah. Yeah. That makes a lot of sense. Sure. Yeah.
Yeah, so that's how we've been using it. To be perfectly honest, the code example that we have on our website is a sort of vision of what an easier to use DSPy might look like. That may not, I think as we've explored the idea maze, that's not actually what we've built. As we explore the idea maze, what we're finding is that one of the key leverage points is having meaningful and reliable evals, because if your evals aren't calibrated, then what are you optimizing against?
Right.
So we've zoomed onto that problem. One solution we found is this decomposition into very specific,
Okay.
unambiguous
Okay.
binary classifiers. And now we're exploring how do you generate those evals iteratively based on
Okay. So and this will be the last question I ask because I want to obviously, would the Ragas sort of folks be a competitor to Zenbase, like just conceptually just trying to get my head around what you're trying to do?
I think this is very fresh. Based on our conversations yesterday, we're trying to sell to the C-suite and not to the engineers themselves.
Gotcha.
So
Okay.
Ragas is
Interesting.
selling to the engineers, we're selling
Okay.
to the C.
Okay. All right. Thank you. Appreciate it. And thank you very much for presenting today.
Thank you. Appreciate your questions.
Hey, Cyrus, thanks for that presentation. Question was, are you finding prompt hell to be a same problem across non-English languages? Are you finding a lot of companies dealing with that, or is that very early days? And if so, are you finding the same kind of techniques that would apply to non-English languages as well?
That is a really good question, and I have not had the pleasure of talking to a company that has, I'd say, like an esoteric language that they're working with. We've worked with English and French so far, roughly the same. You still get this like prompt whack-a-mole thing, but other than that, I don't have enough data to give you a confident answer. Are you experiencing prompt hell in another language?
I have a multi-language search app, and there's people searching stuff in all different languages. And I have
Okay.
it hosted on things like HindiAI.com and a bunch of other domains. So I was
Okay.
just curious, because you did mention this is early days, and I'm just trying to ideate a -1 to 0 solution, perhaps.
One idea is always have separate models slash prompts for different languages. That could work. I mean, if you're prompt, I would imagine that if you prompt the model in the language that it's supposed to respond in, it'll get it better, at least for pre-reasoning models. Might be different post-reasoning models, but I have not had the pleasure to, or maybe not pleasure, but the experience in that specific domain to guide you with something that I'm
Can I
confident.
follow up here? I'm curious, what is the main couple of like pains that you're facing with these multi-language use
Mhm.
cases?
It's not, I mean, it's not quite a pain. I think I'm trying to see if there's a market for people using AI tools in non-English languages. And that's what these MVPs are. They're just essentially just LLM wrappers right now. And then I'm trying to see if I can find customers for, I guess, an AI consulting thing where a non-English documents or reg around non-English documents might be a thing. Again, it's like very, very early exploratory work. It's not like there's not a lot of users kind of
Yeah.
facing this right now.
I can maybe make like 2.5 comments. I think the first comment would be sort of if you look at the models from Cohere, they are the ones that probably care the most about multilingual. And so I think some of their like the Aya model, for example, is like multilingual, like strongly multilingual in about like 20 something languages. They have multilingual embeddings, and so search does quite well. And so if you kind of know the languages up front and whether or not they are covered by the big models, that's one aspect. So in terms of like finding a niche, I think it would be mostly identifying languages that are not well described in the training data of other businesses. Like for example, like there was a whole Japanese language GPT-4 team, and when GPT-4o came out, GPT-4o beat the Japanese only GPT-4. So like even within your own business, it's like if there's a lot of data, there's a lot of Japanese, like the main model is going to beat a specialized model too, is what they've discovered. And so competition is going to be very hard. Whereas if you focus on very rare languages, that might be more of an angle. Like Facebook built a Burmese specific language model. And that is because the Unicode for Burmese is like very strange and it doesn't fit well in like the like many English languages, right? There was like some token inefficiencies where 10 words in English is I think 4 tokens, but 10 words in Burmese is 50 tokens. I'm just making that number up. But so there's some value there in the tokenization. I think the second issue might be around dealing with problems that have a lot of translation, but usually they just come to their own languages. So when I built out a bunch of different meeting taking apps, what will happen is you'll go viral in Denmark, and all of a sudden, like the Danish translations, half the time the summary is in English, half the time the summary is in like Dutch. How do you figure this out? Those end up just being prompting issues. And when it becomes big enough, you are motivated to just solve that problem individually, right? If 20% of our traffic is Danish, like we can just we can just hire like a translator for $800 and just have them write a good prompt. That's generally the case that we've seen. It's if you're actually making money, it's just worth having it in multiple languages. Speak.com, for example, they have custom education prompts in every language that they teach. That's kind of like something they do. Speak.com does like a language learning app, is a language learning app that uses LLMs.
Yeah, I was familiar with Speak. Okay, that's good to know. Thank you for that insight.
Yeah, I would really see if there's like a rare language to tackle. But then if it's a rare language, it's probably not as
Yeah, it's
successful
not a very
commercially.
big TAM. Yeah. Yeah.
Yeah. Were there any other questions that people had? Only about 5 minutes left. We can probably also wrap it up early. Sweet. Cyrus, thank you. I think I would love to sort of see, I mean, maybe we can just catch up online, offline as well, but just some of the more work on just experimenting with few shots. I just shared a blog post where most of the prompt optimization I've seen is either determining what are the optimal few shots to put into the prompt at once, or what is the optimal set of few shots that we can dynamically retrieve at any given time. That's generally how I've been thinking about doing prompt optimization. And in the near future, some of the things I'm going to be exploring are basically data mining examples to find the few shots. And so, for example, I've been working with a bunch of VC firms that are trying to do like due diligence. And we might come up with a rubric today that the VC people really care about. We can define the rubric and then mine examples out of the accepted and rejected candidates. And then we can have the VCs label them as good or bad examples. And so it's like one thing that we're looking at right now is just they want to evaluate how well the founders know each other. Okay, given this rubric of how well do the founders know each other, extract all the snippets out of all the accepted and rejected applications, label those as like good or bad on the rubric, and now they become the few shots of that rubric.
I see.
We can dynamically choose which of the examples to then apply to the prompt to create features such that another model can predict like the probability that we would invest in them score.
Makes sense. Let's talk about that later.
Yeah, so there's a bunch of fun stuff there, but it's been very interesting. We end up just having these LLMs produce binary scores, then we train like a XGBoost model to predict probability of interview.
Did you see that paper where Llama is a better linear regressor than scikit-learn?
That's a little depressing. We should take a look at that.
That's a fun one. Anyway,
Better
thanks for having
for accuracy, but maybe not for latency. But we'll see.
True.
All right.
Thanks for having me, Jason. Thanks, everybody.
Take care.
Peace and love. Take care.